Alright guys, let's talk about lesson 3, which is drawing particle diagrams. Particle diagrams is something that we're going to start now, but it's going to transition into different parts of the year, so make sure that you have a really good grasp on how to do this. So what are particle diagrams? Particle diagrams show how the forms of matter look in a simple diagram form. So there's different types of particle diagrams. The first type is an element particle diagram, a monatomic. So that's one atom. Mon means one atom. So they're single atoms not bonded to each other. So these red spheres are all individual atoms. Notice how they're not touching each other. And since they're not touching each other, that is representing that they're not bonded to each other. A diatomic element are two of the same elements that are bonded together. So these yellow spheres here, since they are overlapping, that is signifying that they're bonded together. And since they're the same color, that means that they are the same element. Compounds are going to be different. Compounds are two or more different elements chemically bonded together in a definite or whole number ratio. So for example, for carbon monoxide, we need one carbon, one oxygen. So in this picture, the carbon are the black spheres and the oxygen are the white spheres. Since they are overlapped, they're being bonded together. So this is a carbon monoxide molecule, this is a carbon monoxide molecule, and so on and so forth. Water's different. Water has two hydrogens and one oxygen. Oxygen we normally signify as being red, so the red spheres are all the oxygens, and the red spheres are the oxygens, and the white spheres in this picture are the hydrogens. So we have one water molecule here, one water molecule here, one water molecule here, and one water molecule here. These are all pictures of two different compounds because they're made up of two different elements. If we have a mixture, that's a combination of elements or compounds or both. They're not in fixed ratios and they're not bonded together. So if I were to draw a picture of a mixture of an element and a compound, this is what I would get. The green spheres are our element spheres, and then these molecules are our water compounds. So remember, it's everything that is touching in a particle diagram means that it's all attached to one another. So let's look at some practice. How would you classify this picture of a particle diagram? Is this an element, a compound, or a mixture? Pause the video and then unpause when you're ready. What did you come up with? You should have came up with that this is a compound. They're all attached to each other and there's more than one element here. The black elements signify one kind of element and the white spheres signify a different kind of element, and they're all attached and not attached to each other, so we're looking at a compound. What about this picture? What would you consider this to be a picture representation of? Pause the video and unpause when you have an answer. Great, what did you come up with? You should have came up with that this is a mixture. All of these dots are different elements. The black dots signify one kind of element, and the white circles signify a different kind of element. Since they are not bonded together, they're not a compound, and since they are all mixed together, they signify a mixture. What about this picture? What does this signify to you? What did you come up with? You should have came up with that this is an example of an element. All the black dots represent the same atom, and they're not attached to each other, so it's not a compound. There's not more than one kind of dot in this picture, so they're not a mixture. What about this practice problem? It says, which particle diagram represents a mixture of element X and element Z only? Pause the video and unpause this when you're ready. Great, what did you come up with? You should have came up with the fact that number 4 has only elements of X and Z represented. Particle diagram 1 shows a compound because the black element X and Z are attached to each other. This has a compound and X and Z by itself. These are also compounds. Picture 4 is the only representation where you have atom X by itself and atom Z by itself, which signifies, remember what the definition of an element is. An element is just one atom all by itself. Alright, now what I want you to do is I want you to use the symbols of X and Z, and I want you to draw two particle diagrams, and particle diagram that you draw for compound 1 and compound 2, they need to be different. You can't have the same. So make sure you're arranging your black and your white dots accordingly so that you get two different compounds. We are going to talk about this first thing tomorrow.